So, some things now about the neurophysiological basis of learning. There are some 86 billion neurons and 85 billion non-neuronal cells in the brain, according to Herculano Huzel 2009, and manifold synapses. For example, one neocortex neuron from these billion ones has an average of 7,000 synapses, as Drachman 2005 says. No DNA code could carry enough genetic information to predetermine these connections, nor would that be desired in order for plasticity to exist, as Carpenter 97 says. If it was predetermined, there would be no plasticity. We could not learn new things. Many animals or lower life forms, so to speak, come with pre-installed hardwired motor programs. So, for example, you may see an animal that at the very moment it gets born, it can run, while men need something like months before they can walk. But you see, the less motor programs are pre-installed, the more capacity a being has to learn. If you see insects, for example, they have much less capacity to learn new things than, let's say, a mammal. Okay, but that comes at a cost, because you have to learn things that other beings have pre-installed in them. Long-term alterations in synaptic activity are the effect of learning. This is what Mai et al. 2013 says, and Bliss and Collingridge 1993 say as well. One could even call learning as long-term potentiation, which is the process by which the neurons establish mnemonic traces for long-term availability. So learning by means of long-term potentiation both induces physical changes in the way the brain is formed and learning is explained by them. It's explained by these changes through the synaptic effectiveness that is a function of the patterns of activity that pre and postsynaptic cells have experienced through, for example, NMDA receptors, which appear to be significant, the NMDA receptors, for both learning and memory formation. Processes such as enhancement of active connections or degeneration of inactive and useless ones, as well as synaptogenesis and altered morphology, are all the results of learning activities. Many researchers support this. Carrillo 2013, Ungerleider 2002, Carpenter 1997. According to many researchers, such as Kleindienst et al. 2011 and Triplett et al. 2009, wired together is the modus operandi of active brain learning processes. Neurons that are associated are paired. Sensory cells develop for themselves a selectivity to those particular patterns that occur in the environment. This sensory adaptation enables the motor system to learn through practice to produce the desired effect, using sensory feedback to modify the responses when not successful, the responses, according to Paulsen 2000, Carpenter 1997. The phenomenon wired together does not only happen in specific regions of the brain, but may include different cells from different parts of the brain, most notably in the case of cerebellar learning, where the paired association of the gigantic Purkinje cell firing in sync with parallel fibers results in strengthening of the connection from one, the Purkinje cells, to the other, the parallel fibers. Mauch 1997 and Carpenter 1997 also mention that process. In this specific case, all the subject will need to do is deliberately initiate a sequence that corresponds to a moving pattern, and the cerebellum executes the whole pattern automatically and rapidly from then on. That is, if I want to play a piece in the piano, if I'm an expert player and I know the piece, I will play it automatically, but I have to start the first chunk of each sequence so that the cerebellum can take over and play the rest. This is why in the distal method sometimes we treat our body and even our brain as separate systems, because when someone tries hard, he gets in the way of letting their body perform, and this is the mechanism for this. The cerebellum, which consists of the cortex and the nucleus resembling a small brain, back here is the cerebellum, is able to store and execute specific sequences of actions by means of a gradual process in which the sequences are first generated consciously from higher brain centers as long as the subject is attempting to master a given task. But as a result of repetition, the execution of the pattern is gradually taken over by the cerebellum itself. Many researchers have studied this phenomenon, like Molinari 2008, Mauch 1997, Carpenter 1997, Schneider and Shine 2003. So this is the essence of the automatization of motor skills. We let the cerebellum take over, and we practice how to do this, how to let our cerebellum, we train our cerebellum, and then we have to let it take over. Mossy fibers, via the granule cells and parallel fibers, carry information from a very wide range of sources, directly from vestibular and spinal afferents, mainly from muscle spindles and visual, auditory, and spinal afferents, and also indirectly from various sources and through the cortex. Apps and Garvich 2005, Cohen and Yarom 1998, Carpenter 1997 also describe this process. Therefore, one can speculate that practicing attentively and in a focused fashion and utilizing more senses results in a better quality of learning. Let me say that again. Practicing attentively in a focused fashion and using many senses, one improves their learning. The basic structure of the cerebellar cortex, as well as the spinocerebellar interactions and motor coordination, are presented in these pictures from Apps and Garvich 2005. Information consolidates in the learning-related areas of the brain, which consists of pyramidal and satellite cells of neocortex and hippocampus and Purkinje cells of the cerebellum, so that memory becomes permanent, and this is long-term memory. The time needed for this process varies significantly based on the respective system, during a period of between 20 minutes minimum to several hours for synaptic consolidation, and weeks to years for system consolidation, meaning system consolidation, the process of the development of independence from hippocampus. You can refer to Dudai 2004 or Shadmer 1997 for this. So, consolidation. Consolidation refers to the progressive offline process that transforms new and initially labile memories from short-term memory into more stable representations that become integrated into the network of pre-existing long-term motor memories. The minimum integration time is 6 hours, according to Krakauer and Shadmer 2006. Consolidation also refers to the memory phase or phases during which such presumed stabilization takes place. Boutin 2012, Dudai and Eisenberg 2004, Magog 2000. All these refer to this process. Items in the long-term memory undergo consolidation just once. or maybe more. Let's see about reconsolidation now some things. Reconsolidation is a hypothetical process in which a consolidated memory item is rendered transiently malleable shortly after its reactivation. This is a definition by Dudai 2006. The reconsolidation hypothesis leaves the possibility open that consolidation occurs more than just once per memory item, according to Dudai again. And this is important since it explains how memories may trick us, since they do actually change. What we remember now about a past event may be different, not only from what really happened back then, but also from what we remembered about the same event in the past. Hopes, expectations, new learning, experience, trauma, all these change mnemonic traces. You may be honest and certain about the memory you have, but the memory may have changed in the process.